Welcome to clickmyproject.com. Let me discuss about the process automated fiducial localization in CT images based on surface processing and geometric prior knowledge for radiotherapy applications. Let me discuss about the process automated fiducial localization in CT images based on surface processing and geometrical prior knowledge for radiotherapy applications. Initially, the scanned images from the patients were first pre-processed in order to remove the noises from them. For pre-processing, we are using median filter. The denoised images are initially classified using KNN classification algorithm. For feature extraction, we are using GLCM algorithm. The features extracted were passed into the KNN classifier so that the classifier classifies the images into normal and tumor-affected images. If the images are tumor-affected images means, then the region of the tumor is segmented using nearest neighbor algorithm. The region growing method is used for the segmentation of the tumor from the images at each stage, and for each region we check if there are unclassified pixels in the 8 neighborhood of each pixel of the region border, and then the particular regions are grouped and then they are displayed. So we are obtaining the tumorous portions from the tumor affected images. The accuracy of the classifier is measured. Let me discuss about the flow of the process automated fiducial localization in CT based on surface processing and geometrical prior knowledge for radiotherapy applications. Initially, the CT images obtained were pre-processed. Pre-processing is used to remove the noises from the image. The noise refers to the unwanted pixels in the image. The noisy pixels reduces the quality of the images, so it is necessary to remove the noises from the image. We use some filters in order to remove the noises from the image. In this process, we have applied median filter. The median filter considers each pixel in the image in turn and look at its neighboring neighbors in order to decide whether or not it is a representative of its surroundings. Median filter replaces the pixel values with the median of neighboring pixel values. The median is calculated by first sorting all the pixel values from the surrounding neighborhood into neighboring order and then replacing the pixels being considered with the middle pixel value. Then we move on to the classification process. Initially, the features were extracted from the pre-processed images. The features were from the chosen region of interest or extracted for further processing. Shape features such as area, extent, orientation, solidity were essential in order to get better classification results. We extract texture features. The texture features are extracted according to the statistics of the gray level co-occurrence matrix. A co-occurrence matrix, also referred to as a co-occurrence distribution, is defined over an image to be the distribution of the co-occurring values at the given offset. It represents the distance and the angular spatial relationship over an image subregion of the specific size. The GLCM is created from a grayscale image. The GLCM calculates how often a pixel with a gray level value occurs horizontally, vertically, or diagonally to adjust the pixel values within the value. Then we are processing the texture features extracted from the trained images and the test image into the classifier. Classification is done using KNN classifier. In pattern recognition, the K nearest neighbor algorithm is a non-parametric method for classifying objects based on the closest training examples in the feature space. In KNN, the function is only approximated locally and all the computation is deferred under classification. The KNN algorithm is amongst the simplest of all the machine learning algorithms. An object is classified by the majority vote of its neighbors, with the object being assigned to the class most common among its k neighbors. If k equal to 1, then the object is simply assigned to the class of that single neighbor. The same method can be used for regression by simply assigning the property value of the object to be the average of the value for its k nearest neighbors. It can be useful to weight the contributions of the neighbors so that the nearest neighbor contributes more to the average than more than the distances one. Like this, using the KNN classifier, the images are classified into tumor affected or normal images. If the images are normal images, then the process ends here. If the images are tumor affected, then we are going to the process of segmentation. In the segmentation process, we are using region growing segmentation. The goal of the image segmentation is to find the regions that represent the objects or the meaningful part of the objects. We use region growing segmentation in order to segment the deceased part in the image. In the first step of the region growing, the seed point is selected. The seed point is selected based on the user criteria. The initial region begins at the exact location of the seeds. The regions are then grown by from the seed points to the adjacent points depending on the region membership criterion. The criterion should be, for example, the pixel intensity, gray level texture or color. At each stage for each region, we check if there are unclassified pixels in the 8 neighborhood of the pixel region border. Before classifying, the region homogeneity is verified. The two regions are merged on the basis of the arithmetic mean and the standard deviation. By comparing the to the serial points, the values are matched, and if the values comes under the value, then the regions are combined. Thus, the single selected regions are grown in order to get the overall tumor affected regions. Let me discuss about the flow of the process. Automated facial localization in CT based on surface processing and geometric prior knowledge for radiotherapy applications. If you want to run the code, select the main.ym file which is located in the source code folder. Right click it and click on run file. You will get the user interface which is needed to run the code. So this user interface contains some buttons, and while clicking the buttons, the operations will be performed. First, to choose the input image from the dataset that we have given. So this dataset contains some tumorous affected images and some non-tumor images. When you give tumorous images, the tumor regions will be segmented. Initially the images are classified as tumorous or non-tumorous, and then if it is tumorous affected means then they are segmented. So initially pre-processing is done using median filter in order to remove the noises in the medical images. Then the image is classified into tumorous affected or non-tumorous affected. For classification, we have to train the database. So initially the training features were extracted, and then the features are extracted from the test image. Then the classifier gives the result as tumor affected or normal image, and the accuracy of the classifier is also measured. If the region if the input tumor image if the input CT images has tumors, then the tumor regions were segmented. Here the tumor regions are alone segmented from the images, and then a contour is plotted over the tumor affected images. If a non-tumorous input image is given means then the process will never move on to the segmentation concept. So initially the features were extracted and they are segmented as normal, and the accuracy is also measured. Then while we click on segmented, there is no tumor to segment. So this is the process. Thus we are identifying whether the given CT image is tumorous or non-tumorous, and then we are segmenting the tumor region from the CT image. Thank you.